Welcome to another video of Math with Jonas, where I take the complicated and make it simple. Today we're going to be looking at multiplying and dividing fractions. We're going to start with a little bit of what's the whole idea, what's the concept behind it. You can know the tricks, but if that's all you know, well, in most cases I find that students just tend to forget, or when something changes, when it gets a little bit more complicated, they have no idea what to do because all they have is a trick in their tool belt, not actual knowledge. Before we get started, though, why is it so hard to type a fraction on a computer? I mean, we have flown to the moon. We give people body parts. We're using AI to. People are going to turn 180 soon with AI, but we can't type a fraction on a computer. I don't know about that. I think we need to revisit that briefly as a society and make typing fractions on computers easier. If you do, hopefully you don't skip ahead. I would love you to see the first part, but if there should be a marker in the video if you want to skip ahead to just see how the practice problems are done. All right, so let's go ahead and get started. Our first concept here is that, multiplication is just addition. I don't want you to forget that. It's often forgotten and you think it's its own thing. So let's just take a look at this example real quick. 6 times 4. Now, most of you can probably calculate that in your head, but remember that where it comes from is it says take the number 6 and add it to itself 4 times. And if I take out a lot of that verbiage, it turns into 6 4 times. So 6 plus 6 plus 6 plus 6. And of course that is 24. Now of course I could do 6 times 5, 6 times 6 and just keep writing it out, but I'm not going to do that. Let's just look at a couple of the quirky examples though. So here 6 times 1. And again, without all the verbiage, that says 6 one time. And that leaves you with 6. Another quirky one is 6 times 0. And that says take 6, add it to itself 0 times, or 6 0 times. And that leaves you with 0. Now, if we throw in fractions, which is what we're getting into, if we have something like 6 times 1/2. So what the heck does that mean? So it's going to sound a little funny, but what it means is take 6 and add it half a time. Just to show you that visually real quick, let's do a handy dandy number line. Very good for picturing numbers and things like that. So here's 0, here's 6. Just as a reminder, this over here was 6 times 0. And this 6 over here is 6 times 1. So again, it says take 6 and add it half a time. So that means we got to figure out what is halfway between 0 and 6. Dun, 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 dun. On the picture, it's about right here. And you should be able to come up with the number 3. And you can get that by counting. So this number here is halfway in between. And that is 6 times 1/2. And if we just follow a pattern here real quick, if we had 6 times 2/2, well, that says take half of 6, but add it together twice. So that's 3 plus 3. Of course, there's other ways you can do that, but that's what I'm showing right now. And the last one on this page, if we have 6 times 3/2, okay, that says take half of 6 and add it to itself, or add it together 3 times. So 3 plus 3 plus 3. And you should be able to come up with that being equal to 9. If you see other patterns with the numbers in these problems to get 6 and 9, or even the 3 up here, you're one step ahead. Okay, we're going to look at the similar idea and just one thing on this page, but we're going to use only fractions. So we got 1/2 times 1/3. So again, in words, what this says, and it's a little bit funny, I feel you. I know it's a little bit funny in words, But this says take the number 1/2, or take a half, and add it 1/3 times. So not a full half even, just 1/3 times. So I'm going to use, I love with fractions, my handy dandy boxes. I guess in this case, just one box. So here's a box. We're going to pretend that's all one line. And we're dealing with a half. So let's take our whole box and split it in half. And it's about approximately right there. Okay. So there we have a half in this top half of the box, but we want to add it 1/3 times. So similar to when we had 6 times 1/2, we had to figure out what is the half of 6. We're going to do the same thing here. What is 1/3 of this half of the box? So I'm going to take this top half and split it into thirds. So we're just going to use 2 lines, and bang, we got this top half of the box is split into thirds. So we have 1/2, and we're going to add it just 1/3 times. So that's representing this part right here. And before I write the answer, it might help for some of you to see this. Since we're now dealing with something even smaller than a half, let's just split the bottom part into the same, into thirds as well. And now you can see, what do we have shaded in our whole box? We have 1/6. Okay, and again, maybe you're looking for a connection between the numbers we had with 1/2 times 1/3 and our answer 1/6. Okay, in the last part of the concept overview, maybe put a hand on your head so in case your mind explodes, but division is also just addition. It's just backwards. And you should know that division and multiplication are very much related. They're just pretty much opposites of each other, but also kind of the same thing. I'll save that whole explanation for another time, though. So here we're going to look at 8 divided by 2. And again, I know you can solve that. That's not the point here. So what this is saying is, how many times do you add 2 to get to 8? So remember the multiplication, we're looking left to right. Now we're going backwards. How many times do you add 2 to get to 8? 2, 4, 6, 8. And of course, I know you know the answer was 4 already. But I want you to think about it from that perspective. How many times did we add 2 to get 8? So now let's bring in fractions to this. So let's say we have 4 divided by 1/3. So again, in words, we're saying, oh, how many times do you add 1/3 in order to get 4? And I'm going to go ahead and bring back my handy dandy boxes. And because we're dealing with the number 4, okay, there's one box, but we're dealing with the number 4, so I'm going to make 4 boxes. There's 2. There's the third one. And let's make a 4th one like that. And now we want to figure out how many times we add a third. It's tough to do with our boxes right now, so similar to what we just did, we're going to split these boxes into thirds. And there's the first one. And don't worry, if you're ever drawing stuff for math, don't worry if it's perfect. As long as you understand what's going on, or if it's something you're giving to someone else, like your teacher, as long as you both know what's going on, then you're all good. Okay, so how many times do we add a third to get all 4 full boxes? Well, in this case, we can just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 4 divided by 1/3 is going to be 12. And again, maybe you're looking for a connection, a pattern between these numbers that you see here in this answer of 12. All right, the very last thing we will look at before just jumping into all the practice problems is, what about 4 divided by 2/3? How do we figure that out? And with this one, I think it would be a little bit easier to do some shading. So I'm going to shade on my boxes here. We have our 4 whole boxes. and they're already split into thirds, so that's good. But we want to see how many times we add up 2/3 to get to 4. So let's go ahead and shade in 2/3. Okay, there's 1 time. And we can do that again here. There's 2 times. And we got 3 times for the third box and 4 times for the fourth box. However, you'll notice that not everything was shaded, so we're not quite done yet. Okay, but remember that we have done it 4 times already. And now don't get hung up. You can shade things in the different boxes. So let's find another 2/3. So that's 1/3, that's another third. Okay, so that there is 2/3. So 1, 2, 3, 4. This together makes 5. And then these last 2 would make 6. So 4 divided by 2/3 is 6. And again, can you find the pattern? Can you find the connection between 4, 2, and 3? And what do you do with those numbers to get 6? All right, so now we're going to just jump into the practice examples I have. I've got whole numbers mixed in, fractions mixed in. One of them's got 3 fractions, mixed numbers, all kinds of good stuff. All right, in this first one we have 8 times 9/12. My first tip for you is if you can ever simplify a fraction, and in this case I'm talking about 9/12, if you can simplify a fraction, just do that right off the gate. So let's just go off to the side here. We've got 9/12. So if I can divide both by the same number evenly, I can simplify that fraction. It'll be the exact same value. So here 9 and 12 can both be divided by 3. And we're left with a 3 up here and a 4 down here. So really the problem we want to look at is 8 times 3/4. It's going to get us the exact same thing. It's just a simplified version. Helps our numbers. It helps make our calculations easier. So what I always recommend, especially if you're not an expert at this, what I always recommend is if you have a whole number, go ahead and make your whole number into a fraction. So we have 8, and with a whole number you can just always put it over 1, because 8 divided by 1 is still 8. We have kept it at the number 8. We're good to continue. So here we want to multiply the tops, right? You can think of it like I've got 8 panels and 3 panels, so we want to multiply the tops. We have 8 times 3. And then we also now want to multiply the bottoms. That kind of gives us the dimensions of the box, or how it's cut up. And that's now we're factoring in 2 different types of boxes. So on the bottoms we have 1 times 4. You could do a simplify at this step. I'm going to skip that for now, but you could simplify the 8/4 into 2/1. But I'm going to skip that for now. So we do 8 times 3, we get 24. And on the bottom we have 1 times 4, which is just 4. And you can think of this like you're simplifying a fraction. You can also at this point, especially with these numbers, just read it like a division problem. 24 divided by 4 is 6. If you simplified, you would have gotten 6/1, and which is also 6. Okay, so far so good. Here we have a similar example. We've got division and our fractions first. So we got 3/5 divided by 6. And what I'm going to do is I'm going to make this 6/1. Okay, so a couple things to remember. A weird example in words, but it's how many times are we adding 6 to get 3/5? So we know just by thinking that way, it's got to be a pretty small number, smaller than 1, because we got to add up to 3/5. So this is where it gets a little bit funny, but no need to fear. When we're dividing, remember that division and multiplication are very similar, but they've got an opposite relationship at the same time. So what's super helpful is instead of dividing by 6/1, we're going to take this 6 over 1 and do the opposite and write 1 over 6. And because we're doing that opposite thing, now we're talking about multiplication. Okay? These two things are the same. Dividing by 6, or 6 over 1, and multiplying by 1/6 are the same thing. That's that opposite but kind of same relationship they got going on. And now again, we can multiply the tops, and then we can multiply the bottoms. And I'm not going to focus on it too much this video, but if you are a step ahead, you can simplify 3 over 6 into 1 over 2 and just calculate with those numbers. But here we're going to multiply 3 times 1 and get 3. We're going to multiply 5 times 6 and get 30. And now we want to see if we can simplify. It's kind of like having a clean house, right? You have people over. You kind of want to have a clean house. It's nice and neat. You don't want everything to be a mess. Similar to 3 over 30, it's a bit of a mess, these numbers, and we can clean it up. We can make it much neater. So we're looking for something we can divide 3 by, and also we can divide 30 by, and that would be 3. So if we take 3 and divide it by 3, we get 1. If we take 30 and divide it by 3, we get 10. Okay, and we can say 3 over 5 divided by 6 is 1/10. So you have to add 6 1/10 times to get 3/5. Fascinating. All right. In this example, we've got two fractions, and maybe this is even easier than the first two examples. Let's just jump straight in because it's all ready to go. We can multiply the tops. 2 times 1, multiply the bottoms, 3 times 3. 2 times 1, we can get a 2 from that. 3 times 3, we get a 9 from that. All right, so if you were to take 2/3 and add it 1/3 time, that would actually be 2/9. That would actually be 2/9. And I know saying in words is one of those mind benders, but it is good to be aware of, especially when the numbers aren't so wild. Okay, in this example, we have 3 over 8 divided by 1 over 10. So we're going to use that whole same but opposite relationship with times and divide. So we take 3 over 8, and we're going to take this 1 over 10. What's the in this case, what would that opposite be? Well, flip it upside down, and that's 10 over 1. But because we flipped it upside down, we can't keep it as divide, or you've just changed the problem. Can't do that as much as you want to. So we got times here. Again, if you're a step ahead, you can simplify 10 over 8 into 5 over 4 and calculate with that. But again, I'm not going to go into depth with that this video. Here we multiply the tops, 3 times 10. And we can multiply the bottoms, 8 times 1. 3 times 10 is 30. And on the bottom, 8 times 1 is 8. And you always want to see if you can simplify your fraction. I'm not going to talk about the whole clean house again, but you want to see if you can simplify your fraction. One general tip I have is just look at both the numbers. Are they both even numbers? Yes. Well, divide them by 2. 30 divided by 2, that's a half hour divided into 2 sections, so that's 15 minutes, or we get 15. 8 divided by 2, if we cut that in half as well, we get 4. And nothing's going to divide both into 4 and 15, so we can stop there. And we get, how many times do we add 1/10 to get 3 over 8? And it's 15 over 4 times, or 3 3/4 times, okay? All right, mixed numbers, everybody's favorite. 5 1/4 divided by 2/5. So what I always recommend with mixed numbers, you know, I've gotten to the age, I don't like mixed numbers. I'm not a big fan. Maybe talking about certain things, that's fine, but not when I'm calculating math. You know, when I'm doing math, I want nothing to do with mixed numbers. Uh, no one likes them. And so we're going to take this 5 1/4 and we're going to convert it. So we're going to make it just a normal looking fraction. So convert, and we're going to make it a normal looking fraction. I'm sure it's got a fancier name, but we're going to just make it looking normal. So again, think of the boxes. This means I have 5 whole boxes, and then there's a 6th box, but I only have one of the panels, right? So if you want to see kind of what I'm talking about, 1, 2, 3, 4, 5, and I've got a 6th box, but just part of it. Okay. So think of all these other ones as split up into fourths, right? That means I have 4 panels in the first box, 4 in the second, 4 in the third, 4 in the fourth, 4 in the fifth, and only 1 in this 6th box. Okay, so how many panels is that? Well, we can do 5 times 4, and that's going to get us 20 panels in these first 5 boxes, and then we got to add this the 1 panel we have in the last box. So in total, 5 times 4 is 20, plus that remaining panel, that's 21. So we have 21, and our boxes are split into fourths. So just real quick, if I didn't write that, if I didn't put that there, then I'm saying I have 21 boxes. That's not true. I have 21 panels, so or fourths. So we write 21 over 4. And again, we have this divide by 2/5. Let's use that relationship with multiplication, that same but opposite thing going on. So we're going to take 2/5 and the opposite, or flip it upside down, and we're going to make it 5 over 2. And because of that, we got to change divide into times, right? Otherwise, we're changing the problem. And now we can solve this problem. So 21 times 5, that's 105. If you haven't watched my video on how to do mental math quickly, what I did was 20 times 5 is 100, but I'm also going to add the 1 times 5, and that gets 105. So go check out the mental math video if you haven't already. On the bottom, we have 4 times 2, and that gets us 8. These do not simplify. 2 and 4 do not go into 105, so or 8. So we can write it like that. If you do want to express this as a mixed number, it looks like it would be 1 or 13 and 1/8. So if you're, I know some classes say write it as a mixed number, that would be the mixed number there. All right, here we've got 2 mixed numbers, 3.5 times 2.5. So again, we're going to just take both of these and convert. So convert and convert. So just a reminder of that process. We have 3 whole boxes, and then we have half a panel. So in our 3 whole boxes, we have 3 times 2 panels, and then we got to add this extra one. So 3 times 2 is 6, and we add the extra one, we have 7 panels, not 7 boxes, so we got to stick it over 2 still. And then here we have 2 times 2, and then we'll add that extra 1. So 2 times 2 is 4, add the 1, that's 5. And again, our boxes are split into 2 panels, so we just write that down also. And this is multiplication, so we got nothing funny going there. We just write the times symbol. All right. And now we can multiply the top boxes. 7 times 5, that gets you 35. 2 times 2, that gets you 4. And you got 35 over 4. If you're in the mixed number category, well, this is really close to 4 times 9, but it's not quite. So that means we have 8 and 3/4. Because that's the most you can have of that fraction before you get to 9. Okay, we got one last example here. In this example, we've got three fractions. We've got multiplication, we've got division, and in this particular example, I am going to explore, when I was talking about if you're a step ahead, you can cancel and make it easier, I am going to explore that in this problem. And that's to help you avoid headaches when there's much bigger numbers involved. So first thing I want to do is look at each individual fraction, 16 over 9, 27 over 2, 1/3. Can I simplify any of those? Because if I can, let's do that. Unfortunately, I'm mean, and my example doesn't have any of those that simplify. So let's move on. Now, first step is, what I would recommend is just let's get rid of division symbols. Remember, it's got that same but opposite relationship with times. So let's just rewrite our problem. We got 16 over 9 times 27 over 2. And we're going to take this last fraction because we're dividing by a third. We're going to flip it upside down, 3 over 1, and then make it times. Okay. So when you're in this situation, and big note, notice there is no plus or minus here. There's no plus or minus. Everything I'm about to say is completely different if you're adding or subtracting things in your fractions, especially with variables. So what we can do, you don't have to look at just one fraction top and bottom. You can simplify using any of the numbers up top with any of the numbers on the bottom. So for example, this 27 and this 9 right here. One's up top, one's below. So we can simplify 27 over 9. And that can be written as 3 over 1. Now let's keep looking. We have 16 over here up top, and we have 2 over here on the bottom. So we can simplify 16 over 2, or 16 divided by 2, or what happens if you, if you're a little bit more advanced, what happens if you cancel out a factor of 2 from both of these numbers? Well, this one, if we take out, or if we divide it by 2, we get 8. And if we also divide this number by 2, we get 1. Okay, let's go ahead and clean this up a little bit. So you'll see this is just fraction times a fraction times a fraction. So we multiply all the tops. We have 8 times 3 times 3 over 1 times 1 times 1. And let's go ahead and go over here. Mental math, what I usually do is, because you can multiply, if you're just multiplying three numbers, you can multiply them in any order you want. So I'll start with the smaller ones. 3 times 3 is 9. 9 times 8, that's 72. And we have 1 times 1 times 1, that's just 1. And if we clean that up, we would just write the number 72, because 72 divided by 1 is just 72. All right. So that about wraps it up for multiplying and dividing fractions. I hope you saw the beginning part of the video and kind of understand, the roots of what it means to multiply, what it means to divide. I think that'll make it a lot easier for you to actually understand what's going on with all the quick little tips and tricks with multiplying and dividing fractions. As always, if you like the video, go ahead and smash that like button. You're doing me a big favor. And if you haven't done your good deed for the week or for the day, how often are you supposed to do a good deed? Is it for the week or for the day? Gosh, I'm not a good person, am I? Also, if you're liking what you see on this channel, go ahead and hit that subscribe button and feel free to leave a comment. Of course, if there's anything you would like to see, you'd like me to make a video of, just drop it in the comments, and I'll see you on the next one.